Exercise 3.5, question number 1 and 2 given in the previous video. We are starting from question number 3. Question number 3, solution. This is exercise 3.5. First number, classify the following numbers as rational or irrational. You see it is root over 81, and 81 we can divide by 3, 27, again by 3, 9, again by 3, it is 3. So 81 can be written as 3, 3, 3 into 3, and this 3 3 can make one pair, this 3 3 another pair, and we know from square root inside to outside, from one pair we can take out one factor, from this pair one factor. So it is 9, and 9 is a rational number. Irrational numbers basically where the root over remains, say root over 3, root over 5, these are irrational numbers which we have discussed in the first video. These are irrational numbers. So rational number, second part in the question, you are asked to write it in p by q form, fraction form. So 9 can be written as 9 by 1, which is in p by q form. First question solution. Then second question, root over, question number 3 to root over 12. 12 can be divided by 2 6 then 2 3 so it can be written as 2 into 2 into 3, and 2 and 2 can make one factor, and from one factor one pair you can take out one factor, and root 3 will remain, and since root over remain, so it is a irrational number. It is a irrational number. We have discussed irrational numbers are neither terminating nor recurring decimal form. Then 3, 1 is done, 2 is done, 3, 3. See, it is given 0.3333. 3 is repeating, or we call it a recurring decimal. And when it is recurring decimal form, it is a rational number. Only one digit is repeating, 3 is repeating. And you are asked to make it in p by q form. So second part, it is like this. The given number, you can take it x 0.333, and you mark it equation number 1. And equation 1 multiply by 10. Why multiply by 10? Because one digit is repeating. If in the repeating block, we call it repeating block, if one digit multiply by 10, if two digit is in the block, we will multiply by 100. Number of zeros you will take exactly equal to the number of digits in the repeating block. So here only one digit is repeating, multiply by 10 both sides. So left hand side 10x, right side if I multiply by 10, left side it is 10x, and when multiply by 10 we know digits, decimal the point goes one digit right. If 100 then 2 digits, if 1000 then it will go 3 digits right. So in this case decimal point will go only one digit right, so it will become 3.33. It is repeating, so we can write we can write any number of digits there, no problem. After decimal point, it is 3 is repeating, it is infinite, it indefinitely goes on. So you write 3 digits, 4 digits, 5 digits, no problem. This is equation number 2, and then equation 2 minus equation 1 implies LHS minus LHS, 10x minus x, and RHS minus RHS. You see RHS here it is 3 minus 0, and after decimal point both are having same number of, you see same number after decimal point, so same it will be cancelled. If you subtract it will get cancelled. So only remaining 3 minus 0, and 10x minus x is 9x is equal to 3, implies x is equal to 3 by 9, implies x equal to 3 cancel, so it is 1 by 3. That means the required number 0.0333 is 1 by 3 is equal to 1 by 3, which is in p by q form. So given number, it is a rational number because it is in repeating form and is equivalent to, or it is equal to 1 by 3, which is made in p by q form. Then question number 3, 4, it is 0.12345. 12345. It goes on indefinitely. That means it is in repeating form. You see, repeating block. There is a repeating block in the decimal form. 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, it will go on. And since there is a repeating block, we call it recurring decimal form, and it is a rational number. And now the second part is to make it in P by Q form. And given number, you can just take it x. Let x is equal to 0.12345, 12345, repeating. You mark it equation 1, and then equation 1 multiply by 1, and how many zeros we have to take? Equal to number of digits in the repeating block. How many digits? 1 2 3 4 5 digits repeating. So we'll multiply by 1 and 5 zeros. That means 1 lakh both sides. Then what we will get here? 1 lakh, 1 and 5 zeros, x. And this one, when we multiply by 1 and 5 zeros into 0.12345, 12345, it goes on, and then left hand side will remain same, 1 and 5 zeros. And because of this multiply, decimal point will shift 5 digits right, because 5 zeros are there. 1 2 3 4 5, it will go here, decimal point will go here, so it will be 12345.12345, and it is repeating any number of blocks. You write here any number of you can repeat. So you mark it equation number 2. 1 2 3 4 5, again another block you write, no problem. 1 2 3 4 5 dot dot dot. Then equation 2 minus 1, LHS minus LHS, 1 0 0 0 0 x minus this x, equation 2 minus equation 1. Right side you see 1 2 3 4 5 minus 0. This 1 2 3 4 5 minus 0, and after decimal point you see the number is exactly same. So if we subtract, it will get cancelled. So will remain only before the part in the before decimal point. 1 2 3 4 5, and here 0. Then it will be, if you 1 lakh minus this, subtract, it will be, then you subtract, it will be 9, 1 2 3 4 5 6 digits. So there will be 5 9, 1 2 3 4 5 9 will be there, x is there, and right side will remain same, 1 2 3 4 5. Then you can just find out what is x. It is 1 2 3 4 5 divided by 9999959, and which is in P by Q form. And this is the solution for this question. Then question number 5, 3 5, you see 3 5, it is 1 0 1 0 0 1 0 0 0 1 dot dot continued. You see it is not repeating form actually. You can see only 0 and 1 are repeating, but when you see in the repeating block, you can see first block there are 2 digits, second block 3 digits, then 4 digits, like this. There is no equal number of digits, so you cannot say it is in recurring form or repeating form. So this is not a rational number, it is a irrational number. It is a irrational number, not a rational, that is a irrational number. Then last one, you see 3 6, it is 23.5 6018561 2 2 3 9. There is no repeating block, you see, there is no repeating block. So this is not a rational number, it is a irrational number, you can mention. Then question number 4, exercise 3.5, question number 4, that is the last question actually. The number 0.9 bar is a rational number. Using algebra, multiply this and explain this exactly equal to 1. So you see 0.9 bar, let it be x. So 0.9 bar means 9 is repeating, 9999 it is repeating. You can mark it equation 1. Now equation 1 multiply by 10, as we have discussed. If one digit is repeating, in the repeating block only one digit 999. So when one digit, then multiply by 10. If two digit, multiply by 100. The number of zeros will be exactly equal to the number of digits in the repeating block. So here only one digit repeating, so multiply by 10. So it will be left side 10x. I'll write here 10x, right side multiply by 10, 0.999 dot dot, and 10x remains same. If we multiply by 10, one digit decimal point will shift one digit right. So it will be 9.9999 dot dot continued, and you can mark it equation 2. Then equation 2 minus equation 1 implies LHS minus LHS, 10x minus x equal to RHS minus RHS, 9 minus 0. After decimal point, you see exactly same, it will get cancelled. After decimal point, you can write, it is repeating, so any number of 9 you write, it will be same. Then 10x minus x is 9x is equal to 9. So x is equal to 9 by 9, x is equal to 1, that is 0.9 bar, 0.99 repeating is equal to 1. That is the complete proof.